All right, so this is our second conversation that we are going to have on the endocrine system. We started out the first time talking about the glands and major structures that you have within the endocrine system. And this time we're going to switch a little bit and get into the hormones. In talking about the glands of the endocrine system, some of these hormones already did come up. It's hard to talk about those structures without talking about the hormones that they work with or they use. So as we go through today's conversation, you might recognize some of the hormones because we've already talked about them, but then I also will be introducing some new hormones. I also want to talk about some of the ways that hormones impact the body outside of just their main targets, and really focusing on fat deposition and how those hormones are going to impact where we store our excess fat. So looking at the first slide, it talks about the fact that we have 40 to 50 different hormones that are used in the human body. And getting a range of number values is not unusual. When we talked about how many muscles there were in the human body, it was not a set value. It was a range. Same thing with the hormones. We see it here again, 40 to 50 different hormones. This is because the experts disagree sometimes on how to count different hormones. And so that is why we see it somewhere in the neighborhood of 40 to 50. Now, with those 40 or 50 hormones, even though that seems like a big number, the body does try to be as efficient as it possibly can with those hormones. So you would use the same hormone in your body when you are extremely excited about something, and it would be the same exact hormone that would be dumped into your body if you were extremely scared about something. The difference is you perceive it as being something different because of the fact of everything else going on around it. So if you are somebody that loves to go on roller coasters and you are on that ascent going up for the first big drop and have really been looking forward to this, you're going to have hormones that are dumped into your system and you are going to perceive that as being a very exciting situation, looking forward to it. On the same token, if you were just involved in a car accident and it's something that is very scary to you, that is the same hormone that is being dumped into your body. But because the roller coaster ride is something you were looking forward to and the car accident is something that you are fearful of, then like I said, how you perceive it, that is going to be very different. Same hormone, but different conditions surrounding it. And so you understand it or you interpret it to be different. So even though we have a large number of hormones, we still try to be as efficient with the hormones that we do use within the body. The last piece that you have on there, we talked about hormones being chemical messengers, allowing those body parts that are not directly connected to each other to still be able to communicate. And that is vital for our survival because of the fact that your brain has to know what's going on with your stomach. It has to know what's going on with your heart, for you to be able to make changes. So we have these hormones, these chemical messengers, but we have to also know when we need to put them to use and which ones we need to use. And so that is very important, that your brain is able to get that information and then put the right hormone into your body to carry out that communication piece. If you go to the second slide, it talks about some of the major hormones of the endocrine system. Now, I just mentioned that we have 40 to 50. I'm obviously not going to do all 40 or 50. I'm just hitting the major ones that are used within the human body. Again, some of these might look familiar. We did talk about them the other day. Some of them will be brand new. So if you start with that list, the first one, ADH, that is antidiuretic hormone. And you will find very quickly with the hormones that they like to give them long names and then abbreviate them down. So the first one that we're starting off with, it's antidiuretic hormone, and it is abbreviated as ADH. So antidiuretic hormone, I also put the secondary name vasopressin in there. You can use either one. They are both perfectly acceptable. But what ADH will do is it is going to cause your body to hold on to any excess water. So again, our human body is going to work off of a time frame where water was not readily accessible. I always go back to like caveman era. So when we didn't know where our next meal was coming or if our next meal was coming, when we didn't have easy access to water and all of those things, our body designed several systems to be able to allow us to maintain and hold on to and reuse as much material as possible. That's why we can't just slough off excess calories. If we overeat and have more calories in our diet, we go back to that caveman era of, okay, we don't know if another meal is going to come anytime soon, so we're going to hang on to these calories. Likewise, when water was not readily available, our body designed a way to be able to hang on to that excess water. And that's what ADH, or the antidiuretic hormone, does. Today, getting access to 64 ounces of water is much easier than it ever was before. Most of us still don't drink 64 ounces of water in a 24-hour time period. But if we don't have enough water in our system, that ADH is going to be released. That tells our kidneys that we need to hang on to as much excess water as we possibly can. And so the kidneys will withhold as much water as they possibly can. Not all the water, but they will pull back as much as they can and put it back into the bloodstream so we can maintain it within our body. One of the things that you will notice when that happens, when that excess water is pulled out, it is going to concentrate your urine, and that's when you see your urine turn into those darker yellow colors. You have urea, which is going to be excreted from the body in your urine. If you have a lot of excess water that you can get rid of, it dilutes that urea, makes it a very pale color. If you're having to use a lot of antidiuretic hormone and pull a lot of that water back into your body, it's going to pull it out of that filtrate material, concentrating that urea, and your urine is going to appear much darker in color. The next one that we have on the list is calcitonin. This is one that we did talk about briefly the other day. We focused more on the parathyroid hormone, but calcitonin is a hormone that is going to be released into your body when you need to decrease or lower the amount of calcium that you have in the blood. So our bones are storage tanks for calcium. Calcium is very important, number one, for our muscle contractions and also for bone strength. So muscle contractions cannot happen without that calcium. And if our calcium levels are not where they're supposed to be, we are going to start utilizing calcitonin and parathyroid hormone to regulate those levels. Now, in the case of calcitonin, this is going to be used when you have too much calcium in your bloodstream. So for whatever reason, you've taken in a lot of calcium and your blood levels are very, very high, calcitonin will be released. It will cause that calcium to be pulled out of your blood, and you will actually build more bone tissue. So it will actually take the calcium from the blood and pack it into bone to store it there for a later time. The next one that you have on the list is cortisol. Cortisol is a stress hormone, and it is released in those time periods where you are out of your comfort zone. So there are a variety of reasons that people get stressed out, and some things that will stress out one person do not stress out another person. So this is something that is very relative to the individual, when and how much cortisol is actually released. So it is, like I said, a trigger or a response to someone who has found themselves in a stressful situation, and tends to be situations that are somewhat prolonged. So not just a quick instance of stress, but something that is weighing on you, that you constantly kind of keep going back to and keep thinking about. That cortisol is then going to be released into your body in response to that stress. Then we have epinephrine and norepinephrine. This is going to be the hormone that is released, again, in times of stress, but this is going to be fear. So you have been confronted with a situation in which you are out of your comfort zone, but you are also scared at the same time. And now we're into that fight or flight response. So are you going to stay and confront the situation and deal with it, or are you going to flee the situation and see if you can get away from it? Epinephrine, also referred to as adrenaline, and the changes that we see in the body, you are going to have that, and we did mention this the other night, that blood distribution. So blood is going to go to the head, it's going to go to the hands, it's going to go to the feet, so that no matter what you decide to do, you have the blood in those areas. Increased blood distribution to body parts is going to increase the oxygen to those body parts. And if you go back to conversations very early on in the year, oxygen is the driving force behind cellular respiration, specifically that electron transport chain. So building ATP in the body, the electron transport chain is going to utilize oxygen molecules. And if you remember, the first two parts of cellular respiration made 2 ATP molecules each, and then we get to the electron transport chain where oxygen is used to make ATP, and now we're building 32 ATP molecules. So that oxygen is very, very important to our ability to make a lot of ATP. And so that's why that blood distribution is so important. But it will allow you to see better when it goes to your head. It will allow you to process information faster so that you can make better decisions, quicker decisions. The feet and the hands, so you can either fight or flee at a higher rate than you normally would be able to. The next one that we have on the list is estrogen, progesterone, and these are typically thought of as female hormones. Please understand that women have estrogen, guys also have a certain level of estrogen. It is far less than that of a female, but guys do have levels of estrogen in their body. Likewise, testosterone is thought of as a male hormone. Females do have testosterone in their bodies as well, on a much lower level. When we look at estrogen and progesterone, this is going to be the hormone that is going to trigger the development of sex characteristics. So all of those transitions that we think of during puberty, the widening of the hips, the start of the menstrual cycle, formation of body hair in places where it wasn't before, all of those things are going to be brought about because estrogen levels are going to increase in the female body. Just below that, the testosterone, that is going to be responsible for causing the development of male sex characteristics. So again, all of those transitions, the lowering of the voice, the broadening of the shoulders, development of facial hair and things like that, that is all going to be brought about by testosterone. And then we get into FSH. FSH is follicle stimulating hormone. So when we look at follicles, it's actually referring to the sex cells of the human body. So we have the egg cell in the female, the sperm cell in the male. And the follicle stimulating hormone is going to trigger the egg production and the sperm production. Now, in females, the eggs that they have been with them since day one. They are actually formed when we are still inside mom. So we have the eggs with us, but because there's going to be a very long window of time between our birth and when we actually need to potentially use those eggs, we keep the eggs in a dormant phase, and then FSH is going to trigger those eggs to finish off their development so that they could potentially result in a pregnancy. But you don't want them ready to go at birth, because basically they would be sitting around for 12, 14, 16, 20 plus years before they would eventually, before the female would be entering into puberty and ultimately be hoping for a pregnancy to result from that. Sperm production is a little bit different, and guys, we'll get into that with our reproductive chapter, but that follicle stimulating hormone is going to be what triggers those eggs and those sperm to finish off their development so that they could result in a pregnancy. And then we have the melanin stimulating hormone. This is going to be a hormone that is going to cause our skin to darken due to sun exposure. We talked about this when we did our integumentary chapter, which again goes back to first semester. But you have melanin embedded within your skin cells, and when you get hit with UV rays, it causes that melanin production. And then the melanin is going to come to the surface of the skin, and ultimately that pigment, that melanin, is going to cause your skin to appear darker. In actuality, what it's doing is it's blocking those cells from UV exposure, because that UV exposure will disrupt how your DNA is formed. And obviously that's problematic. So we try to self-shield our body as much as possible. Obviously sunscreen is also a very good idea if you are going to be have prolonged sun exposure. So that MSH is just referring to that melanin, the hormone that is going to respond to that sun exposure and needing higher levels of pigment to be produced. The second slide that you have with the hormones, that is going to be, the first one is glucagon. This is going to increase your blood glucose levels. So if for some reason you are not getting in the carb calories that you need through your diet, you do have in reserve, specifically your liver is going to be one of the largest places for those stores, but you do have on reserve this glucagon, and if needed, like I said, because you didn't get enough in through your diet, what you were eating on a given day, you actually can release this hormone, and it will then cause the glucose that is stored within your liver to be released into your bloodstream so that you can carry on with what you need to do to get through your day. The next one that you have, HGH, that is the human growth hormone, and it is going to trigger, just like its name, the growth of different body structures. So it will increase in size your bone structure, your muscles, your internal organs. When you have growth spurts, it is because you have an excess amount of HGH that is being dumped into the body. Some people will take it as a supplement to kind of jumpstart growth and things of that nature. This is one of the hormones that is going to stem from the pituitary gland. So this is one that we did discuss last time as well. But like I said, just targeting those body parts and causing that increase in size and development with those body structures. Insulin was another big one that we talked about when we discussed the pancreas. So insulin is going to be used after you eat a meal and you're breaking down the food. You are going to break down that food into the most basic parts. Okay? We went through that when we went through our digestion chapter. As that food gets broken down and that material gets released into your bloodstream, one of the things that's going to start to show up in higher levels in your bloodstream is going to be glucose, simple sugar. That glucose is necessary to start off our cellular respiration process. And so it's very important to be able to get the glucose from your blood into your cells. That doesn't happen on its own. Your cells are shut off from glucose, so to speak, and they have to have a way to be able to cross over. And the insulin is going to be that key that is going to be able to take that glucose from your bloodstream and get it into your cells so that your cells can put it to use in the process of cellular respiration. If you don't have insulin or you don't have insulin in the right levels, that transition of getting the glucose out of your blood and into your cells where it can be consumed does not happen. And as you continue to eat and that glucose does not get pushed out of your bloodstream, those glucose levels will continue to rise. That is what you guys know as diabetes. The sugar levels can actually get so high in someone who is suffering from diabetes that their urine will have a sweet smell to it. You should not have glucose in your urine. But if the levels get so high, the body will eventually push it out, void it through the urine, and it will have a sweet smell to it. Somebody who is in very high stress diabetic situation will also have a fruity smell to their breath. And again, it's because of that very high sugar content that they have going on in their blood because they lack the ability, that insulin hormone, to get the glucose from their bloodstream into their cells where it can be used. The next one that we have on the list is LH. This is luteinizing hormone. Luteinizing hormone is going to also be tied to the reproductive system, and its job is to kind of regulate estrogen and testosterone production. So estrogen levels change throughout the month depending on what's going on. And so as those levels fluctuate, that is in part because of the luteinizing hormone. And if you watch luteinizing hormone production and estrogen production, they actually simulate each other. There's a little bit of a lag between the two, and we'll talk more about this when we go into our reproductive chapter. But as one changes, a couple of days behind, the other one will change, and it will carry out the different changes that the female goes through during the monthly cycle. On testosterone levels, so LH really doesn't have much to do in little guys. When baby boys are born, they have a certain level of testosterone, and then shortly after birth, their testosterone levels drop off, almost non-existent, and they will stay that way until they hit puberty. And then once they hit puberty, those testosterone levels will spike back up and carry on all the changes that they need for development, but also that sperm production is very dependent on testosterone levels. And that is all because of that luteinizing hormone. We have melatonin, which we did talk about in depth, that regulates your sleep and wake cycles. The next one that you have, oxytocin. This is going to, number one, trigger your contractions during childbirth. So as more oxytocin is produced, the intensity of those muscle contractions of the uterus are going to become more intense as well until baby is born. The secondary part of oxytocin is actually emotional attachment. So there was a study done where they looked at animals that abandoned their young or destroyed their young shortly after birth. And what they found was that those animals have very low levels of oxytocin. They've also done studies in humans as well, just to see oxytocin levels and the attachment of mom and baby and dad and baby after birth. And what they have actually found is that that connection between the parents and their child, they can actually monitor the changes of oxytocin being produced in those bodies, especially when there is skin-to-skin contact. So when mom holds baby skin to skin, her oxytocin levels increase, baby's oxytocin levels increase. And just that ability to attach and bond with each other. They also did a secondary study that looked at dads. And again, when dads had that contact with baby, that skin-to-skin contact, their oxytocin levels increased, baby's oxytocin levels increased. So it is a very important hormone that we have, not only for the actual process of childbirth, but also after baby is here, just building that attachment and that bond between baby and their parents. Prolactin, that is going to trigger your milk production in mom. So as prolactin levels increase, that is putting more of a demand on mom to produce more milk. And this is in response to ultimately how much baby is demanding. So as the baby grows and develops, their need for more calories and for more nourishment is going to increase. So as baby is demanding more, that is going to, the brain is going to tell the body to start producing more prolactin. As those prolactin levels increase, the body will produce more milk and it will accommodate the child as needed. So as long as there is that stimulus from baby, the demand for milk, those prolactin levels will stay high and continue milk production. As baby demands more, they will continue to increase until mom decides to stop nursing. The next one that we have, PTH, the parathyroid hormone. We did spend some time on this the other night. This is going to be the counter hormone to calcitonin. So calcitonin and parathyroid hormone work against each other. Calcitonin is going to work when your blood calcium levels are too high. Parathyroid hormone is going to work when your blood calcium levels are too low. So if parathyroid hormone is dumped into your body, it is going to cause your body to destroy or break down bone tissue. It will actually dissolve the bone tissue. In doing that, it frees the calcium that was stored in those bones. That freed calcium is delivered to the bloodstream. It circulates through your blood to your muscles, and your muscles will actually be able to then use it to carry out muscle contractions. And the last one that we have, TSH, the thyroid stimulating hormone. This is going to deal with the release and how much of your hormones like T3 and T4, what those levels are at in the body. So again, when we talk about the thyroid, we know that we're dealing with metabolism, but metabolism is going to be dependent on those T3 and T4 levels within the body. Remember, T4 was the inactive form, has 4 iodine molecules attached to it. When we break one off, now we only have 3 iodine molecules, so it's T3, and that is the active form of our thyroid hormone. So the next slide that you have takes a look at hormones and fat deposition. And one of the biggest things is you can look at 2 different people. They can weigh the exact same, but they can have very, very different body types. And one of the biggest explanations for that is actually the use of hormones or hormone production in our bodies. Even though we have the same 40 to 50 hormones, they're not always utilized in the same way. And people will overproduce certain hormones or underproduce certain hormones. And that's just the give and take that you have within the human body. So we have access to the same amount, the same types of hormones, but how much is actually used in our body at any given time will fluctuate. And that actually is linked to where we store fat or extra weight in our bodies. So if you look at the slide that says abdominal fat deposition, for those people that tend to carry most of their excess weight within their abdomen, they have one of 2 hormones that are working against them. So for those people in which, in which they are producing too much cortisol, those high levels of cortisol are actually going to then make it easier for the body to store any excess fat, any excess calories within that abdominal region. So you might have somebody that the arms are skinny, the legs are skinny, but all of that excess weight seems to be focused in that one location. And that is an indicator that they are overproducing or in high amounts of that cortisol hormone. The other one is insulin. So this is a little bit different. So cortisol we know is stress impacted. Insulin is going to be based on the foods that you eat. So if you are constantly eating foods that are highly processed using sugar, your very starchy foods, things of that nature, and you are always asking that pancreas to produce high levels of insulin, that is going to also cause you to store some of that excess weight in the abdominal region, but that is for a very different reason. So if you are stressed all the time, that will be the trigger, but if you are overeating those sugary foods, that also could be the reason why your excess weight is going to be carried within the belly region of the body. The next one that you have is estrogen. If you are a female, you have heard over and over again that estrogen is going to cause you to carry your excess weight within your midsection. So the thighs, the buttocks, the hip area, but it will also cause excess fat to be carried in the upper arms as well as the calves. So bicep, tricep area, and then the back of your leg will be because you have high levels of estrogen within your system. The problem with hormones being involved in fat deposition is that even if you start the process to lose weight, because the fat deposition is tied to hormones and not just calories, it can make losing that weight, especially in targeted areas, very difficult. So you might lose weight, but not in the places you want. So if you start working out to lose weight because you're carrying excess fat in your arms and your calves, you might lose weight, but not from those areas. And so it can make it very frustrating when that fat deposition is tied more to hormones and not solely just on calorie intake. Then we have when excess weight falls to the neck and the trunk of the body. So this is another one that is going to be linked to cortisol. And you might have seen this on a person where they tend to carry excess weight between their shoulders. So on their back, between their shoulders, it has a lot of street terms, none of which I'm going to mention here. But when you have that excess weight carried in that region, more than likely it's because you were overproducing cortisol. So something is consistently stressing you out, and when you store those excess or that excess fat, it's going to go to that back region between those shoulders. It also can be an indicator of Cushing's disease. So it can be a precursor of Cushing's disease, and we'll come back to that a little bit later. The next one that we have is muscle mass issues. So for some people, no matter what they do, putting on muscle mass can be very difficult. This is actually an indication of low testosterone levels. Again, this is a hormone that we see in both males and females. But if you have somebody who either, number one, cannot build muscle mass, so they're going to the gym, they're lifting, they're working out, but they're just not increasing in size, it can be because the testosterone levels are too low. You also can have a situation where, because of other things going on in the body, because of low testosterone levels, the existing muscle mass is actually deteriorating and breaking down. So low testosterone levels, number one, can make it very hard to build muscle mass, but it also can cause the existing muscle to deteriorate, break down, and actually start to become smaller. So the last piece that I put on that slide, just a quick indication that yes, both men and women have testosterone. Guys are going to have about 40 times the amount of testosterone compared to a female. So it is very, very different when you compare the two genders. The last one is if you have even fat deposition. So you really don't have one targeted area in your body where you tend to carry your excess weight. It just head to toe. All those extra pounds are just kind of evenly distributed throughout. That is a very good indicator that there is something wrong with your thyroid and the thyroid hormone production. And that would be something that you would want to get tested and checked out. Please understand that these are just some of the hormones that are related to fat deposition. There are a lot more, but just to kind of get an understanding of how hormones play a role in the body, it's not just that communication piece, but they also can impact and disrupt a lot of other things that take place within our body. So I just wanted to give you guys a little bit of a taste of that in this second conversation. So on Blackboard, you will want to check for your assignment. I will have a description of what you need to do and bring to our next class. Also, please keep in mind, we are going to finish up the spread of disease lab. We got through the lab, we got through the testing part of it, but now you guys need to be able to have that conversation of who you actually think started the entire infection. So you don't need to do anything with that at this point. You just need to bring it to our next face-to-face meeting. We will open up with you guys having time to finish that up and then get that turned in. If you still have your other lab that we're working on, the urinalysis lab, that you can bring with you, but we will not have any class time to work on that lab. So you need to bring that one with you finished. I will pick urinalysis lab and homework up at the same time, right at the start of class. No time to work on that one.